Have you ever slept in a little bit longer than you should, and that resulting in you being in a rush on your way to campus or work? And if you get there by a bike, there is a great chance that the nearest parking spots are already taken. Then you have to spend a lot of time to find a parking spot, which is most likely very far away. If you're a student, then you will be late for your lecture and you will have to run. What if this problem could be solved in a smooth way that didn't end up in stress? Let's present our solution. We have developed a system for bike parking spot reservation. The system consists of an application and a bike lock realized with a Raspberry Pi recognizing NFC tags and a server.
So say you want to reserve a lock. When you boot up the app, the phone asks how many locks are available from each rack. The user can then reserve a lock at any particular rack. If the reservation is approved, a timer, depending on the distance between the biker and the lock, is started. The biker then has that much time to reach the rack, lock his or her bike in the rack before the reservation expires.
When you arrive, the parking spot will flash with a yellow LED saying that the spot is reserved. The bike lock that you reserved will detect your NFC tag, which can be a smartphone, a card, anything with an NFC tag. Then, presenting your NFC device to the rack, the bike will be locked on the rack. The red LED will now flash, saying that the bike rack is busy and that the lock is in its locked state. When you're done for the day and you want to ride your bike back home, you use your NFC device to unlock your bike by simply presenting it to the NFC reader.
The physical prototype bike lock consists of several parts. First, the Raspberry Pi, which houses all the software needed to run both the rack and the locking mechanism. Second, the NFC reader, which publishes a message each time an NFC-enabled device, such as a phone or a keycard, is held in front of it. If the correct keycard is presented or no reservation has been made on the lock, a signal is sent to the motor through the motor control unit. This unit enables both clockwise and counterclockwise rotation. Attached to the motor is a locking pin which locks the bike in place. The system is comprised of three main parts. First, a smartphone app used to reserve the bike locks. Second, a central web server which serves both the bike locks with reservations and the phone app with markers for the bike racks. Third, the rack unit, which handles incoming reservations and the locking mechanisms themselves.
Our system makes it possible for you to reserve a parking spot while you are still at home. This way you can take your time biking to campus without stressing about it, and at the same time being sure that your reserved parking spot will be waiting for you when you arrive. You will then get a parking spot near where your lecture is and arrive at a perfect time.